campus networks. Okay, network architectures we have. See how the networks are there in the enterprises. Let's consider you guys work in a big company and that company has multiple buildings. Okay, 2 buildings are there. Now in each building there will be certain departments, and in the departments there will be different switches. Okay, so let's say you have some switches, and with these switches some PCs are connected. Correct? Okay. Now what will happen? These PCs, let me connect them. Now at this building level, I want to centralize the traffic. I want to monitor them from a single place. So what I'll do, I'll use one more switch, and with this switch, I'll connect both the switches. Done. Okay. Same scenario will be there in the other building also. There will also be some switches in the departments, and some PCs will be connected. And there also we will aggregate the traffic with the help of a switch. Correct? Now I want that the traffic from both the buildings should be aggregated. There should be a centralized server room for both the buildings. Okay. So again, one more switch I'll take. And this switch will connect to both the buildings, so that I can get all the traffic from both the buildings. I can monitor and manage. Now, for connecting to the internet, I will need one ISP. Okay. So I'll connect a router here. Okay, and that router is going to connect me to ISP. That's it. This is ISP. Okay, that router is going to connect me to the ISP. This is clear. Any doubt so far? No. Now, my question is, what will happen if this switch goes down? This building traffic gone. So to avoid this scenario, what I'll do, I'll use a backup switch. I'll use a backup switch. Same scenario will be here. I'll be using a backup switch here also. Okay. And this backup switch will connect to both the switches. And I'll connect them so that load balancing can also happen. One switch will not have all the load. This is clear. Okay. Now again, if this switch goes down, what will happen? Both the buildings gone. One more switch. Then connect these both also. Okay. And also connect here. Correct. And this switch will also connect to these both switches. Clear? Means this switch connecting all 4, this switch also connecting all 4. So in case anyone goes down, one will still be there for the backup. Now, what if, let's say I have taken connection from Airtel and today Airtel service is down? Problem. And for problem, we'll use another backup ISP. It will connect here. It will connect me to the, right? Let's say this is R2 and this is R1. Now, sometimes there can be a scenario that this entire router is not down, but only this particular interface is down. That can also be one scenario, right? So in that case, what I'll do, I'll connect here also. And I will configure, see, this will be a directly connected route. But for the same network, I will configure a backup route also through this path. So that in case this interface goes down, let's say some mouse came and eat that cable or anything. Due to some reason, this interface from my primary ISP is down. In that case, I will configure a backup route also so that the traffic can be forwarded through the primary ISP only, but through this interface. Okay. So this is the architecture. Now in this architecture, if you see here, how many layers of switches I have? One, two, and three. Three layers I have. The layer where you connect your end host, that is known as your access layer. This is known as your access layer. Okay. The layer at which the access layer switches are aggregated, that is known as distribution layer. Okay. So if you want that, okay, in this particular department, there should be these many VLANs and all, those things you will configure here. If you want this department should communicate with this department or not, those filtering you will done in the distribution layer. Okay. Is that clear? Okay. And in the core layer, this third layer is known as the core layer that is going to handle all your traffic. Okay. And your core layer switches are the fastest switches in your network because they will be handling the traffic from entire enterprise. Okay. And you will avoid configuring any sort of policies on them. Why? If you will configure policies on these switches, what will happen? They will inspect or they will check each and every frame for that particular policy, right? So if they will check each and every frame, and you can imagine how much amount of traffic will be there. If 2000 systems are available this side, 2000 are available this side, and they're going to the internet, right? So if you configure policies, what will happen? The switch will check for the policies, and you can imagine the amount of CPU that will be used. So we avoid configuring any sort of policies here. Okay, what are the policies we configure that we, oh, sorry. Those policies we just configure only inside the core layer and distribution layer. I mean, the access and distribution. We avoid configuring the core layer. Is that clear? So this architecture is known as three-layer architecture or three-tier architecture. Means we are just understanding how the networks are designed in the companies. This is clear. Now this company having two buildings and all, right? What if there is only a single building company, small company having a single building only? Okay. So in that scenario, what will happen? Only one building. That means departments. In the departments, PCs are connected, right? You will aggregate this. Then you will use one ISP also, right? But if this goes down, what you're going to do? One more backup switch. And if your primary ISP is down, you need a backup ISP also. And then this is your ISP. Just make the connection same way. But difference is this is smaller enterprise having only one company. I mean, one building. Your access layer switches, they will never be connected with each other. Why? Because if you want that one department should not communicate with another department, then filtering should be done. So that you will do on the distribution layer. Okay. Same architecture, just one single building. That's it. Okay. Now here, how many layers? 2 layers, 1 and 2. Again, the layer at which we connect and host, access layer. Now this layer is going to handle all the traffic also. And this layer is going to filter out and aggregate the traffic of access layer also. Means all the task of core layer and distribution layer will be performed on this layer switches. Okay. So this is known as collapsed distribution core layer. Collapsed distribution core layer. Okay. But what is happening here? If the traffic is, you see, the traffic is basically traveling up and down, going up from this layer, coming here, going back there, coming here. Correct? Traveling in this direction. So can I say it is in the north and south direction? The traffic is traveling in north and south direction. So in this architecture, there can be some latency. Okay, some latency will be there. So in data centers, we cannot have, or we cannot afford to have latency. So we do not use these sort of two-tier architecture. This architecture is known as two-layer architecture, or you can say two-tier architecture, because we have 2 layers of switches. Okay, so we cannot afford using 2-tier or 3-tier architecture in your data centers. So for data centers, we have a special type of architecture, separate architecture. That architecture is known as spine and leaf architecture. In spine and leaf architecture, again, you have the switches. Only 2 layers will be there. One will be spine and one will be leaf. The leaf layer is the layer at which all your data servers will be connected. All your data servers will be connected in the leaf layer. And all your leaf layer switches will aggregate at the spine layer. Okay. And this is the spine layer. This is the leaf layer, and these are your data servers. How they are going to connect? See. Now data centers, they can grow very fast. So we should have the scalability option also. Okay. So each and every spine layer switch will be connected to each and every leaf layer switch. Each and every spine layer switch will connect to each and every leaf layer switch. No, this is for specifically for data centers. In data centers, we do not use 2-tier or 3-tier. We use spine and leaf. Okay. Like this. Now, anytime you want to scale this, anytime you want to increase this, let's say you want to add more data servers, you can simply attach one more switch, and you can attach more data servers. Okay. Then after, what you have to do? Just from each and every data server, each and every spine switch, make a connection. That's it. Let's say, okay, these are getting overloaded. Simply just go and add one more switch. Let's say I will add one more spine layer switch. And this spine layer switch, simply go and add it. So you have the scalability option also. And if you see here, the data will be traveling from one data server to another data server only. So your traffic will be, most of your traffic will be flowing in this direction. Which is east and west direction. And this architecture will have less latency compared to your 2-tier and 3-tier architecture. Okay. So that's why in the data centers, this particular architecture is used. Clear? Okay. Now, what if someone is having very small office, working from home itself? So for them, we have the Soho architecture. Okay, that is small office, home office architecture. Small office, home office architecture. In the small office, home office, what is going to happen? There will be one ISP. ISP will give you one connection. Will install a router in your home. You will connect one switch. With the switch, you will connect your devices. What all the devices you want to connect? If you want wireless range also, you will take one cable, connect wireless access point. Okay, and this is going to broadcast wireless signal in the designated area. And then you can connect your smartphones and everything with the wireless also. Clear? But right now, how it is happening? This is ISP. Take a connection. ISP is giving you directly one Wi-Fi router. This Wi-Fi router is having some ports also. With these ports, you can connect your devices with the cable. And if you have wireless devices, it is already broadcasting wireless signal, right? So you can connect your smartphone and everything. This is your SOHO architecture, simple. Small office, home office. If you are working from home, new startup, these kind of scenarios. Clear? Then one more popular architecture these days going on is the cloud architecture, right?
So this dynamic architecture
Mhm.
is also called
Hmm?
application.
I haven't seen that.
So yes,
Cisco. This architecture, I think it is known as spinal leaf. Cisco, ACI. Application Center Infrastructure. This is SDN, different. This is SDN is different. We'll discuss in the automation, SDN. Okay. See, it is already saying here, software-defined network solution designed to help organization manage complex environment by delivering network automation.
the one which we are seeing is SDN, that is Viptela.
That is SD-WAN and SDXS. SD-WAN is Viptela.
Okay.
SD-WAN solution is Viptela.
That's what we will be covering here.
Yeah, in the SD-WAN in CCNP you'll study.
This is SDN.
Yeah, this is SDN. Okay. So cloud. Cloud is what? What is cloud? Means you don't have the servers in the physical location. They will be available in the remote location. Okay. So there are certain cloud architectures. Let me show you. And the different cloud services that I want to show you. Means the servers will be present in the different location. So what I want to show you is cloud services. Okay, see this one. Now, cloud is what they are. You are using someone else's system. Okay, the server, you can deploy a server in two ways. One is on-premise and second is on cloud. When you're installing the servers on-premise means you will have to buy the hardware, all the servers, then operating system, all the licenses and everything. You will have to buy, you will have to install the operating system, you will have to configure all the services and everything. Okay. And other thing is, if you do not have, let's say, startup companies, new companies, they do not have that much of budget, right? So what they will do, they will move to the cloud. Okay. In the cloud, what happens? They don't have to worry about anything. They don't have to worry about buying hardware. They don't have to worry about the maintenance of the hardware. They don't have to worry about security of the hardware. Okay. All the things are taken care by a cloud provider, like your Amazon, AWS, Microsoft Azure, Google Cloud Platform, these kind of scenarios. Now, cloud services are given in three ways: infrastructure as a service, platform as a service, and software as a service. When you're going with the infrastructure as a service, in that, your cloud provider will give you all the hardware, virtualization, and everything. Means he will kind of give you a computer, you can say, virtual machine he will give you. Okay. Now we are discussing about virtual machine. So let's discuss about virtualization also. What is virtualization? Something not physical. So means in one physical system, you have purchased one computer. In that, you are able to use multiple operating systems. That is the virtualization. Because let's say VLAN is what? Basically dividing or creating virtual switches, right? Same concept is there in the virtualization, that one computer will be behaving like multiple computers. Okay, one physical machine will be behaving like multiple physical machines. That is your virtualization. With the help of virtualization, what is happening? They are providing these services. Okay, now what will happen? When you're going with the infrastructure as a service, so they have created one virtual machine in this machine. And let's say you asked for 1 GB RAM, they gave you 1 GB RAM. You asked for 2 CPUs, they gave you 2 CPUs. Whatever cost you are paying, they will create some plans that, okay, if you pay this much, we will give you 1 GB RAM, this much bandwidth and that. So if you are using infrastructure as a service, what will happen? They will give you the virtual machine. Now, what you have to do, you have to install the operating system, all the software services you have to install, and you can use it. Second is platform as a service. Platform as a service is what? They will give you with the operating system also. You just install your program there and start using it. Third is software as a service. Software as a service is what? Everything is given by them. You just have to directly log in and use. Kind of use, you can say Google Drive. What is Google Drive? It is software as a service. Okay. Everything, the operating system, the Google Drive software, everything is installed by Google, managed by Google. Correct? What we are doing? We are just using it. Right? So that is the software as a service. These are the cloud services. Is that clear? Any doubts? Here, you have to manage, you can see operating system also, you have to install applications, data, everything you have to install. But in case of platform as a service, only you have to worry about application and data. OS will be managed by your cloud provider. You are going to manage what is there in the blue color. Okay. So if you are going with the software in the service, nothing, you don't need to manage anything. You just directly go and use it. Is that clear? This is your cloud architecture.